Let me do a tutorial to find the maximum and minimum points for the function of two variables. Example. F of x comma y equals to x squared plus y squared. Solution. Step 1. First derivative test to find the critical points. Differentiate f sub x comma y. Look at here. We have two independent variables x and y, so it's a two variables function. And first differentiate the function with respect to x to have f sub x equals to 2x, and then set f sub x equals to 0 to get the value of x equals to 0. And now differentiate the same function with respect to y to get f sub y equals to 2y, and set equals to 0 to get y equals to 0. Therefore x equals to 0 and y equals to 0. These are the critical points. 0, 0 are the critical points in step 1. Step 2. To find all the second derivative of x and y for the function of f of x comma y. Take f sub x and differentiate it with respect to x first to get 2. If you differentiate f sub x equals to 2x with respect to x, you will get 2. And then again differentiate f sub x with respect to y to get 0, because there is no y variable. There is only 2x. Now take this function f sub x and differentiate it first with respect to x to get 0. There is no x variable. And now differentiate it with respect to y to get 2. Look at here, f sub xy equals to f sub yx. They are always equal to each other. Just put this function in discriminant form and name them a, b, c. For f sub double x, put a, and for f sub double y, put c. For f sub xy and for f sub yx, put b. Substitute the values here. The value of f double x is 2, and the value of f double y is 2. F sub xy is 0, and f sub yx is also 0. Just do cross multiplication to have 2 times 2 minus 0 square equals to 4. Step 3. To find the maximum and minimum points. These are critical points, and if a is greater than 0, which is 2, and b equals to 0, c is greater than 0, and d is greater than 0, which is 4, then the point will be minimum point. Let me show it graphically. This will be my point here in x and y direction. At the origin, this is my minimum points here. But look, normally we don't care about the BC. We only care about the critical points A and D. Always look to the value of A and D and the critical points. Based on that, you identify the minimum and maximum point. And that's all for this topic of maxima and minima differential equation.